Welcome to today's cybersecurity briefing. What if a SIM card could do much more than connect a device to a mobile network? New research from the University of Birmingham and Fuzzware has revealed that a malicious SIM card can potentially send commands directly to cellular modems and, in some cases, execute attacker-controlled code inside the devices they power. The research team tested 26 phones and cellular modules and found the capability enabled on 9 devices. 6 out of 8 cellular modules tested accepted the commands, and researchers successfully used the technique to execute code on a commercial electric vehicle charger. The key issue is a feature called RunAt. SIM cards can use standardized proactive commands to interact with a modem. RunAt allows a SIM to ask the modem to execute at commands, the same control language historically used to manage modems. The problem is that cellular IoT modules are not always just simple communication components. Many contain an application processor running software such as Linux or Android. This can create a much larger attack surface. In one demonstration, researchers analyzed a Quectel cellular module inside an EV charger. A vulnerable software component passed attacker-controlled input into a shell command, allowing the researchers to achieve code execution. The implications go well beyond EV chargers. Cellular modules are widely used in industrial routers, vehicle telematics systems, payment terminals, connected vehicles, and other IoT equipment. These devices are often deployed remotely and may have very limited physical or network interfaces. Importantly, this is not a scenario where simply knowing someone's phone number is enough to launch the attack. The research indicates that a malicious SIM or equivalent hardware must already be present in the device, whether through physical replacement, a compromised supply chain, or another method. The researchers also demonstrated other potential consequences. On one tested smartphone, a malicious SIM could force the device onto 2G. Because 2G lacks modern mutual authentication protections, an attacker could potentially create conditions for further cellular attacks. The research highlights an important cybersecurity lesson. Sometimes the biggest risk is not an undocumented backdoor, but a legitimate feature that provides more power than expected. Researchers say the RunAt interface should be hardened, deprecated, or disabled where it is not required. Qualcomm has reportedly developed a hardened configuration that disables the interface by default, while Quectel has addressed one related file access issue and is working on the broader interface. For organizations operating cellular IoT fleets, the immediate recommendation is straightforward. Contact the module supplier, determine whether RunAt is enabled in the deployed firmware, and ask whether it can be disabled. At the time of the report, there were no known attacks exploiting this interface in the wild. But the research demonstrates how a seemingly ordinary SIM card can become a powerful entry point into connected hardware. As billions of devices become connected through cellular networks, securing the modem itself is becoming just as important as securing the software and cloud services around it. That's all for today's cybersecurity briefing. Stay informed, stay secure, and remember, in IoT security, every interface matters.